Now, another way of representing or visualizing flow motion is with particle path lines. And particle path lines are usually or can be what we experimentally observe because they correspond to the physical trajectory of a material element of fluid. So a material element of fluid which we follow with time. And by material element of fluid, I mean a real small volume of the real fluid. So it's really, we're looking at how a piece of the fluid is moving with the flow. Experimentally, how you visualize that is by seeding small particles in the fluid, and we assume the particle can follow the flow, and we look at the trajectory of this particle as it is transported by the flow. Now, it is important to distinguish and not confuse particle trajectories and streamlines. And so to make the distinction, let's consider a flow field which is unsteady and therefore it will change in time. And so the flow field we are looking at is this one. So this is, again, the ideal flow around a cylinder, which we'll discuss in great length in the second quarter. And we'll assume that initially this cylinder is at rest and there is flow that is flowing around the cylinder. And we'll discuss that in the second quarter, but we'll assume that the cylinder starts to rotate. And by rotating, we are going to model that with a certain amount of circulation, which we'll explain later on in the second quarter. But what you'll see is that the flow on the top will be slowly accelerated and the flow on the bottom will decelerate a little bit. So this is at time equals 0. And then later on, the flow looks like this. You see that the vector fields on the top, they increase in magnitude, and the vector field on the bottom, they decrease in magnitude. All right, so the streamlines, these are fit to a snapshot of the flow field. All right, so the streamlines are always tangent to the velocity field at a given time. So here are the streamlines for this flow. Oops, I zapped one. So here are the streamlines. And you see the streamlines, they are tangent through the flow field at this time. And then at a later time, the streamlines change, but they are always tangent to the entire flow field at a given time. So these are the streamlines a little bit later on, and then again a little bit later on, and these are how the streamlines are deformed. Okay, so these are here streamlines. So how are streamlines different from particle path lines, where we're looking at the same flow? Again, this is the flow at the initial state. So we have a flow which is flowing around the cylinder. Remember what's going to happen. Slowly we're going to start rotating this cylinder. The velocity is going to increase on the top. The velocity is going to decrease on the bottom. Now, and we're going to compute the particle trajectory. So we'll follow this particle here. This is this black particle. And at this given time, the velocity of this particle is equal to the velocity of the flow field at this point. So you'll see that the particle is going to move horizontally to the right. So this is the position of the particle at the next time step. So you see it's moving to the right. But as you can see here already, the flow field is changing slightly. So you see that now the velocity field is moving up a little bit compared to before. Right? But at every given point, so here now the particle is going to move at the local velocity. So at the velocity given by this arrow here that you see under my cursor. Okay? Remember now that the velocity field is changing. So again, when I'm here, you see that the velocity is going to move in the direction of the local velocity field. Same here. So now the velocity field is, the local velocity vector is this vector here roughly, so it's going that way. So you see the particle is following this, and so that black line now is the particle path line. Now note that the particle path line here doesn't really correspond to any of the streamlines at this particular time. So the velocity field here is plotted at the time when the particle is over there. Note that at this point, for instance, the particle path line is not tangent to the velocity field, because it's the velocity field at a later time than when the particle was moving here. Okay, so this is very clear in the following animation. So here you see I will overlap the trajectory of the particle and the streamlines at every given time, and you'll see that they don't correspond. So you see here, this is the trajectory of the particle, but you see that at any given point, the trajectory here doesn't really correspond to a streamline. So don't confuse particle path lines and streamlines.